Right, welcome to today's lecture. This is lecture 4. We're doing applications of differentiation, and we are going to do the gradient of a plane curve. Then from there, we'll do the rates of change. Then we'll also do velocity and acceleration, and then stationary points. So I also wanted us to do small changes today, but I don't think we manage because of time. So just end at stationary points. So what I've done is I'll be explaining, yes, but I've put up questions that will be acting as guideline. Yeah, the questions will be guiding us on what we're going to be doing. So before I solve any question, at least I'll be explaining something that is important on that particular question. All right, so let's quickly begin. Okay. So as we can see, we're starting with the gradient of a plane curve. Yeah, so like I explained when we were doing the first principle, I remember explaining something like, no, the first principle is, I remember explaining something like the first principle can also, instead of writing it as y prime, or for instance, or let us just do this. Let me just do this. Okay. So the first principle, or maybe let me not even begin from the first principle. Let me just say dy dx. Whenever you have been taught to find dy dx, which sometimes is the same as f prime of x, if the function is in terms of f of x. Sometimes if the function is like this one, which is just y is equal to something, you can either write it as dy dx or just y prime. It still means the same. So all these, they represent the gradient. So when you find the first derivative of anything, that's the gradient of that particular thing. Yeah, so if you have a function like this one, like the one that we've been given here, yeah. So if you have this function, let me do this. Okay, so if you have a function like this one, and then you've been taught to differentiate this one, or rather to find the gradient of this one. Yeah, in other words, they're simply just asking you to find dy dx. So if you have the function, this same one, let me just copy it. We have y to the power 3 minus 2 to x to the power 2, then plus 3x, then minus 4. So if this is what you have as a function, and then they're asking you to find the gradient of this function at the point 1, 2. In other words, they are asking you to find dy dx or just y prime. So what I'm trying to say is that dy dx is simply just equal to the gradient of a line or a curve at a particular point. Okay, so let us find dy dx. As we can see, this is a polynomial. And when I'm dealing with polynomials, you differentiate independent terms depending with the type of that term. Yeah, depending with the term itself. If, for instance, you have sine theta somewhere, you have to differentiate it accordingly to how, or you have to differentiate it exactly the way you differentiate sine. Okay, so let us find dy dx. So dy dx, the first term there, x to the power 3, this will just be 3 times the coefficient there is 1. So 3 times 1 there will get 3. And then we write our x there, and then 3 minus 1. When we subtract 1 from 3 there, we'll get 2. So we move on to the next one. Negative 2 times the power 2 there. This will give us negative 4. Then we write x, and then this 2 minus 1 will get 1. And then we have this one. This power 1 times 3 will get 3. Then 1 minus 1 will get 0. X to the power 0 is simply just 1. So we can write that one there if you want. Then the derivative of a constant number we said is 0. Okay, so dy dx will be simplified now to, so this one is just 3x squared. Then here we have negative 4x, then we have positive 3 there. So this is our dy dx. Then they're asking us to find the gradient of this function at the point 1, 2. So you can now say the gradient is equal to dy dx. The gradient of this point at 1, 2 is equal to dy dx at x is equal to what? The value of x in this expression is simply just 1. So yeah, in those coordinates, the value of x is simply just 1. So you say dy dx at x is equal to 1 is simply just equal to, in this expression, you just replace wherever there's x, you put that 1 there. So you're going to have 3, then you have 1 there squared minus 4. Then where there's x, you put 1. This is what you get. Then you have this being equal to, this will be 3, then minus 4 plus 3. So when you simplify this, you have 3 plus 3, that's 7 minus 4. 3 plus 3, that's 6. And then minus 4, that will give you 2 as your answer. All right, so this is the gradient they were looking for at this given point there. All right, so let's quickly move on to the next question. So before we can proceed, I don't know if anyone has a question. If you have a question, feel free to ask. Okay. So silence means people are okay with everything. Okay, let me just erase this. All right, so the next question is find the coordinates of the point at which the curve y is equal to x cubed minus 3x squared minus 9x plus 6. Yeah, so after this, I'm going to give you an exercise. Though the exercise that I sent earlier in the morning, only a few have managed to submit. I think about 3 people have managed to submit. The rest, I don't know what was happening. Was the exercise hard? Or maybe it was just time, you never had enough time. Okay. So
sorry. The exercise. Yeah.
Hello? I can't get you clear. What were you saying? Okay, let me just guess what you said. You said the exercise was hard. So we'll find time to go through it together. Preferably, or maybe the next session we're going to have, instead of starting integration, we can't start integration without you understanding differentiation. So we may go back to the exercise. So the second question here is find the coordinates of the point on the curve y is equal to x to the power 3 minus that, where the gradient is equal to 0. So in other words, what you've been told is that the gradient, which is represented by m in mathematics, the gradient m is equal to 0. So we said dy dx is the one that we call as the gradient in calculus. So dy dx is the one that gives us the gradient function. Hence, they are telling us to say the gradient is equal to 0, meaning dy dx is equal to 0. So what we just need to do is we find dy dx of this equation, and then after finding the derivative of this equation here, we simply just equate that answer to 0, and then we find the values of x. So they are asking us to find the coordinates of the point on which this curve has a gradient 0. So let me do this. Then we have the equation is simply just y is equal to x to the power 3. And then we have minus 3x squared. Then we have minus 9x plus 6. So to find dy dx of this function, we simply just differentiate it in the same way we differentiated the first one there. So 3, when you differentiate x to the power 3, we get 3x squared. And when you differentiate negative 3x to the power 2, this will give us negative 6x, and then when you differentiate negative 9x, you just get negative 9. Then when you differentiate a constant, the answer is 0, so you can just leave it. And then they're asking us, rather they are telling us to say the gradient is equal to 0, meaning dy dx is equal to 0. Hence we just equate this same expression here to 0. So meaning we're going to equate this to 0. When we equate this to 0, and then we have to find the values of x, and then after finding the values of x, we also find the values of y. So we're going to have 3x squared minus 6x minus 9 is equal to 0. So this equation is a multiple of 3. So we can divide by 3 to reduce it at least, so that it will be easier for us to solve. So the first one there, 3 over 3, this will just give us x squared. Then we have negative 2x. Then we have negative 3 is equal to 0. So we can factorize this. We find the factors, rather we find the product, the sum, and the factors. So the product will simply just be found by multiplying the coefficient of x squared and negative 3 there. So the coefficient of x squared is 1. 1 times negative 3, we get negative 3. And then the sum is simply just negative 2, just get this part. So the sum is equal to negative 2. So now the factors will be, the factors will simply just be equal to, so we find two numbers that when we multiply them, they'll give us negative 3. When we add them, they'll give us negative 2. And those two numbers are simply just negative 3 and 1. So we have negative 3 and 1. So we replace them in this equation. So we're just solving a quadratic equation. This shouldn't be a problem to some of you, or to all of you in short. We did this last semester. So we have negative 3x, you can start with any factor there, then plus 1, plus x, minus 3 is equal to 0. So what is common there? X is common, we open brackets, have x minus 3. Then here we have 1 is common, we have x minus 3 there is equal to 0. So we have x minus 3 and x plus 1 is equal to 0. Hence the values of x we have are positive 3 and negative 1. So having found the values of x, this means that these are the values of x on this curve at the points where the gradient is equal to 0. So let us find the values of y. So to find the values of y, you say when x is equal to 3, then you say y will be equal to, in this many function, you replace wherever there's x with 3. So y will be equal to 3 squared, 3 cubed minus 3, 2 squared minus 9, 2. This is 3, sorry, not 2. Okay, minus 9, 3, then plus 6. So here is just a matter of simplifying. This is 27. 27, this is 9, again 27. So these two will cancel. Then we have, this is negative 18. This is negative 27 plus, so negative 27 plus 6, that should be negative 21. Yeah, so the first coordinate at which the gradient is equal to 0 is simply just positive 3, negative 21. Yeah, so you just have to make sure that you do your mathematics correctly there. Okay, so you also take the second value of x. You say when x is equal to negative 1, the value of y is equal to negative 1 to the power 3. And then minus, we have 3, negative 1 there, squared of minus 9. Where there's x, we put negative 1, then plus 6. So we simplify this. This will give us negative 1. This will give us negative 3. Then this part will give us, so this part will give us positive 9, then positive 6. So we have negative 4 and 15, which will give us 11. So we have 11. So the other set of coordinates that have the gradient 0 is just, where is the, okay, the x coordinate is -1, then comma 11. So this is the second coordinate. So these are the two values, rather these are the two coordinates which they are looking for. 3, -21 and -1, 11. So these are the answers they are looking for. So do we have questions here before I go to the next question? Okay, so let's quickly proceed. We just erase everything. So the most important here, the most important thing that you just need to know here is simply just mastering that dy dx is equal to the gradient. Whatever that you find, whatever you're going to find in the form of dy dx, that should be your gradient function. And whenever you replace the value of x in the gradient function, the answer that you get is simply just the gradient. Okay. So if they ask you anything concerning the gradient, just know that it's dy dx. So find the equation. Question 3 is find the equation of the tangent and the normal to the curve y is equal to that. So the first thing that you need to know, the first thing that you need to understand about this question is that you've been given the function, and the function is y is equal to 1 plus x minus x squared. Then the question is find the equation of the tangent and the normal to the curve, this curve. Yeah, so how do you find the equation? So we know to say, according to mathematics, the equation of a straight line, because we know that a tangent will always be a straight line to the curve. So this tangent, yeah, is mostly a straight line, not always. Yeah, so this tangent, they're saying find the equation of the tangent. So the equation is found by using this formula, y minus y1. This is according to coordinate geometry, is equal to m x minus x1, sorry. X minus x1. So this is the equation of the tangent. And then to find the equation of the normal, you simply just change the gradient there. We know to say m1 times m2 should give you -1. That is according to coordinate geometry, which you even did in grade 12. All right, so let us find, of course, this question is not complete. I was supposed to specify at which point exactly. So let's say at a point where x is equal to 1. Okay, so find the equation of the tangent and the normal to the curve y is equal to that at x is equal to 1. Okay, let's see. All right, so let's begin now. So we have the value, the function as y is equal to 1 plus x minus x squared. So we find the gradient function. How do we find the gradient function? Simply just by finding dy dx. So when you differentiate the constant there, that will give you a 0. Differentiate x there, you get 1. Differentiate negative x squared. So you say -1 times 2, you get -2. And then x, 2 minus 1 there, you get 1. So this is what you're going to have. Hence dy dx is simply just equal to 1 minus 2x. So after finding dy dx, you can now find the gradient by replacing the value of x in the gradient function. So the gradient will now be found by replacing x there. So we say 1 minus 2, while there's x, we put 1. So gradient will simply just be equal to 1 minus 2 times 1, that will just be 2. So 1 minus 2, this is just -1. Hence, the gradient will just be equal to -1. So after finding the gradient, we can now find the line or the equation of the straight line of the tangent, in short. The equation of the tangent to the curve at this point when x is equal to 1. So how do you find that? You only have x, but the equation is saying you should also have y1. And then in this case, you only have x1. How do you find y1? So you find y1 by replacing the value of x in this equation. So you say y is equal to 1 plus, what is x? We put 1, then we have -1 squared. So when you simplify this, you just get the value of y to be 1. Hence, we have our x1 is equal to 1, and then our y1 is equal to 1 as well. Then our gradient, this is the gradient that we have found, which is just -1. So we use this formula for the equation of the tangent, rather the formula for the equation to find the equation of this tangent. So we say y minus y1 is simply just 1 is equal to, our gradient is -1, then open brackets, x minus x1 is also 1. Okay. So x1 is also 1. Okay. So we close the brackets like that. So let us now multiply, let us simplify the equation. So we have y is equal to, you take this one to the other side of the equal sign, and then you also open the brackets there. So you have -1 times x, this will give us -x, then -1 times -1 will get +1. Then -1, when it crosses the equal sign, to become +1. So the gradient of, rather the tangent, the line, the equation of the tangent is simply just going to be equal to -x plus 2. So if you want, you can just say x plus y is equal to 2. This is the equation of the tangent. So how do you find the equation of the normal? So I've managed to find the equation of the tangent. Let us also now find the equation of the normal. So the equation of the normal, you get, it's the only difference that is going to be there is the gradient. So the gradient, you get it using this formula here. Okay, so what is the gradient? You just get it using this formula there. So you have m1, then m2 is simply just, you can take any of these as m1 and m2, any of the two gradients. So if I take my m1 as the gradient of the normal, then my m2 is just the gradient of the tangent. So we have m1 and then m2, the gradient of the tangent, which we found to be -1. So we put -1 there, then we equate that to -1. So when you divide by -1, divide by -1, the gradient of the normal simply just be equal to +1. So in this expression, we just change where there's -1, we put +1. So we have y minus 1 is equal to 1, open brackets, x minus 1. So you have y minus 1 is equal to x minus 1. When you take this to the other side of the equal sign, you get y is equal to x minus 1 plus 1. Then the value of y simply just be equal to x. So this is what you are going to get as the equation of the normal. So this is the equation of the normal. In case you don't know what a normal and the tangent is. So a tangent is simply just, if you have a curve, for instance, it's like this, then at this point, a tangent is simply just a line that touches the curve at a particular point. So now the normal is simply just the perpendicular bisector of the tangent. So the perpendicular bisector of the tangent is the one that we call the normal. So this one is the tangent, and then the one that cuts the tangent, that bisects the tangent at 90 degrees, is the one that we call the normal. So the equation of the tangent, this one here is this one, and then the equation of the normal is simply just this one. All right, so let's quickly move on to the next question if you don't have questions here. All right, so we also move, we can also talk about increasing and decreasing functions. So when we talk about these functions, before I even start talking about them, let me just explain certain things that you need to understand. So if a function is increasing on one side, for instance, if you have this function, or if you have this curve, then you also have this curve. So when you take the gradient of this side of this curve, you discover that the gradient will be going up like that. This is the gradient to be going up, meaning according to mathematics, when the gradient is going up like that, that means that it has a positive gradient. So in other words, m is equal to positive. So we can say m is greater than, so m is greater than 0. And then m is greater than 0. So this implies that according to calculus, m is found by dy dx. This implies that dy dx is greater than 0. On this other side, where the curve is just, where the gradient goes down, we know to say when the gradient is going down like that, means that the value of m is less than 0. So when the value of m is less than 0, we can also conclude that dy dx is less than 0. Okay. So now we've talked about increasing. So on this side where the gradient is going up, where the gradient is positive, we can say on this side, the function is increasing. So on this side, the function is increasing. And then on this side where the gradient is decreasing, we can say the function is decreasing. And then if at O you have, okay, if you have this part as an increasing part, then you have this part as a decreasing part. What of this part here? This part here, which is neither increasing nor decreasing, just the down part here. Sometimes it can even be on top. So in this case, it's down. Sometimes you can have a function like that, and then it will just be there. So this part, what do we call this? So this is a stationary point. So at this point, where the gradient is neither increasing nor decreasing, we call this as a stationary point. So when it is down there, then it is minimum. So it is minimum. Then when it is up there, we call it as a maximum point. So this is a maximum point. Then this one is a minimum point. And then at this point, at these 2 points, the value of dy dx, or the gradient, is simply just, let me just say the gradient, which is just the same as dy dx, is equal to 0. Same applies to this point here. Dy dx is also equal to 0. We also have another type of stationary point, which we are going to discuss at the end. I'm sure there are questions there. So this one looks like this. It looks like this. This is also a quadratic equation, but it is neither maximum nor minimum. We call it as a point of inflection. So this one has a point of inflection. We're going to discuss this. But for now, let us just focus on this. For now, we're focusing on increasing and decreasing. So let's forget about these 3. We're going to discuss them at the end of this. I've prepared questions on this. Okay, so for what range of values of x is the curve y is equal to x to the power 3 minus x squared minus 9x plus 6 increasing? So they're asking to say for what range of values is this function increasing? So meaning if you want to find the range of values of x for which the function is increasing, I always tell people that in calculus you don't get a zero. If you get a zero on a calculus question, then you just wanted to get a zero. If you know that you have to differentiate, just differentiate. When you differentiate, you get half of the marks. That's the good part with calculus. So here we do. Here you can pretend as if you don't know what to do. So if you pretend that you don't know what to do, the only thing you can do, if for instance it's an exam, you just differentiate. After differentiating, you know that when a function is increasing, its gradient is supposed to be greater than 0. So what I would do is I'll solve for increasing, and then you are going to solve for decreasing as an exercise. I'm going to put an exercise immediately after this. So the same question might repeat in an exercise, but you'll be solving for decreasing. So when the function is increasing, I know that the gradient should be greater than 0. So, and I'm getting that from this part where there's an increasing, which is an increasing part. So we get this function, we differentiate it. So we have this function. So we find dy dx. So dy dx of this function will simply just be 3x squared minus 6x minus 9. So if this function is increasing, we're answering this question here. So if this function is increasing, what you simply just do is you take this greater than 0 symbol, you just put it this side since it's increasing. So you just say this should be greater than 0. So we're going to have 3x squared minus 6x minus 9 is greater than 0. So you divide by 3, divide by 3, divide by 3 to get, oh, sorry, not that, to get the values of x. So let us simplify this. We're going to get that as x squared minus 2x minus 9. Minus 9 is greater than 0. So our main thing here, or the main purpose for doing this, or rather, oh sorry, this one's supposed to be 3, not 9. Yeah, so the most important thing here is just to find the values of x. So remember, I think we solved this question somewhere. I'm not sure, but oh, it looks the same, but I think it's different. Okay, the product here is -3. The sum, no, we solved it. So let me just go there and get the values of x that we found. So the values of x that we found after solving this equation, if I remember very well, there was something like a 3 and, oh, I've erased. Okay, there was something like a -1. Is it -1 and 3? Yeah, there was something like -1 and 3. We had x is equal to -1 and another x is equal to 3. So once you find these two values of x, yeah, so once you find these two values of x, you go on the number line. I'm sure no one can help to factorize this quadratic equation. When you're factorizing this, first ignore this symbol, the greater than symbol, ignore it. Yeah, so just put an equal sign there. In short, you just write something like this. Just write this is equal to 0, and then you find the values of x. So these two values of x that you find are called critical points. So these are called critical points. So now you draw the number line to find the range of values of x. Yeah. Maybe just to help someone out there, let me just solve the quadratic equation. Let me just solve it. Yeah, because there's a point which I wanted to come and make at the end, but maybe some of you might get confused. Let me just solve it, though the time is almost up, but I'll make another link that you have to join. Okay, so we have x squared minus 2x minus 3. So we factorize this. We said okay, let me just factorize it first. We have x squared, and then we have negative 3x, then positive x, then minus 3 is equal to 0. Then from there we say x is common, so we have x minus 3, then plus 1, x minus 3 is equal to 0. So we're going to have x minus 3 there. We'll also have x plus 1 is equal to 0. So this is what we have. Then after finding that, we can now find the values of x. So when you equate both factors to 0, you find that x is equal to negative 3. Is it? Oh, positive 3, sorry. And then we have another value of x as x is equal to negative 1. So these numbers that we found are called critical points. So these are just critical points, they are not final answers. So after finding this, we now draw the number line. So we put these numbers, we have negative 1 there, and then we have 3 there. So the values that are below negative 1, we say x is less than negative 1, which are, these are numbers going this side. And then we have numbers also between negative 1 and 3. Then we also have the numbers which are greater than 3. So we say x is greater than 3. So I'm going to send another link very soon, which you have to join. We proceed. So from there, we start testing the points now. We get any number that is less than negative 1, we test it in this expression here. So we can even get negative 2. So when you put negative 2 where there is x there, we'll get negative 2 minus 3, that will give us negative 5. So I'm not going to write negative 5, I'll just write a negative there. Just get the sign. Then when I put negative 2 there where there's x, I'm going to have negative 2 plus 1, that will also give me negative 1. So I'll also just write a sign there. So negative times negative, this will give me positive. So I'm going to compare this with this expression there. So now